applications of vectors. So there is a plane that takes off and travels at an angle of 40 degrees north of east. So first is you have some terms there, north of east. So when you do this in words, it's going to be like that. But if you're going to do it in letters, you have to reverse the process. So this means east, from east going to the north. So that would be east-north. All right, so if I'm going to draw the angle, so that's 40 degrees because that's east going to north. So this will be 40 degrees. Okay, and then after that, it travels 110 miles per hour for about 2 hours. Remember that distance is equivalent to rate times time. So if you find the distance it traveled after 2 hours, you will have to multiply the speed, which is 110, and the time it takes it to travel that is 220 miles. Okay, so that will be the distance that the plane will cover after 2 hours. Okay, now after that, it will adjust its path by traveling 10 degrees west of north. So you have here west of north. So what does it mean? So this means from north going to west. Okay, so this is northwest. So what should you do? From the point where it stops and adjust from its position, you draw again another Cartesian plane. And it says there that this is again your east, that's your north. It says there it's going to travel from north to west by 10 degrees. So that will be this. This is about 10 degrees. Okay? So that's 10 degrees. Now, remember that this one now, the angle that will form when you intersect the x and y axis is 90 degrees. So this is partly 10 degrees. So therefore, this angle here will be like 80 degrees because 10 plus 80 is 90 degrees. Now, how about this angle here? Okay, the angle here is the same as the angle here because alternate interior angles are congruent. So therefore, this will be partly 80 and partly 40, which will make it 120 degrees. So that's the angle here. Okay, now the problem is asking how far will the plane be from its starting position. So you need to find that side. So if I'm going to separate the triangle looks like this. Okay? So this is 220 miles. This is 120 miles. Now we need to find this distance. It says it will travel for half an hour at 110 miles per hour. So we will multiply 100 by 0.5. So distance 2 is equivalent to 100 multiplied by 0.5, which gives us 50. So this one now is 50. So you're trying to find this path here, the distance from its new position from starting point, and you have a side, you have an angle, you have a side. So this is an SAS situation. It means that we will need to make use of the cosine law. So therefore, to find that angle, now let's say for example, or side, you have your ABC, it doesn't matter when, so you're trying to find C. So C now is the square root of A square, which is 220, plus B square, which is 50 square, minus twice those numbers, cosine of the angle, 120 degrees. So we take the square root of that, okay, and then we will be able to solve the problem. So make sure that our Desmos is in degree mode. Okay, so put those values. So square root of 220 square plus 50 square minus twice those values, cosine of 120. And that's the answer, 248.79 or in nearest miles, it's equivalent to 249. So therefore, our answer is letter D.